today's lesson is going to be over expected value. There's a number of things that we kind of want to go over. Number one, the probability model that the worksheet is discussing is really something that we already know how to do. So just kind of over here on the side, I want to talk about what a probability model is. Number one, you always write out the outcomes on the top, whatever that is, and then the probability of those outcomes underneath it, right? So it looks like this. So you could have any number of outcomes that happen, and we'll kind of take this apart and apply it to each one of the problems here. The thing that I have to remember is that I need to write every possible outcome, and I need to make sure that in those outcomes, the probabilities that I'm assigning to them, they need to always add up to 1. If they don't add up to 1, once I've got them all written down, then I'm either missing an outcome or my probabilities are wrong. So for example, if we look at number 1, it says if you draw a card from a deck, you get a spade, you win nothing. If you draw a club, you get $5. If you draw a red card, you get $10. If you draw an extra $30, or you'll get an extra $30 if you draw the 1 queen of hearts from the deck. Number 1A asks us to create a probability model for the amount we're going to win, right? So in this case, X is going to be in dollars. I could win $0. I could win $5. I could also win the $10 prize or even the $40 prize. Why is it 40, not 30? Because it says there is an extra, it says extra $30, not $30 in general for the Queen of Hearts. So it's already red, so you're going to get $10 for that, plus the 30 on top for being just the Queen of Hearts, right? And so the question is, what are the probabilities associated with each one of these things, right? So if you draw a spade, you get $0. Well, there are 13 spades out of 52. There are 4 suits, spades, clubs, diamonds, and hearts. And each one is 1/4 of the deck, so there's 52 cards total. That's where you get the 13 out of 52. You could also say 1/4 here because that's what it reduces to. If you draw a club, right, here again, clubs, there's 13 out of 52. Hearts, clubs, diamond, all of that's 13 out of 52. For any red card, now we would say there's 26 out of 52. Half of the deck is red, half of it is black. However, we've written this down. There's 1 card in the deck that's going to get me $40. That leaves behind 25 other red cards, right? That's where we're getting our 25 out of 52, not 26, because the 1 red queen, the Queen of Hearts, is going to get me an extra $40. Now, if I add all those numbers together, if we add all of these, they should add up to 1, and they do. If they don't, if I don't get 52 over 52, then I have a problem, right? Either my probabilities are wrong or I'm missing one of the outcomes. The next question, it says to find the expected value of the amount you're going to win. In this case, expected value is really easy. What we're going to do is once we've got this table, expected value is really simple. We're going to take this number and multiply times its probability. And then this number times the probability, and then this, and then this. Then we're going to add all those things together and kind of add it up. And so here we're going to say 0 times 13 out of 52. I really wouldn't do that, but just to illustrate the options, or the operations, 13 out of 52 plus 10 out of 25 over 52 plus the 40 times 1 out of 52. When I do that, we're going to go through that. I'm going to be careful to type that in. My expected value is going to be $6.83. Yep. Now what that means is, so just expected value in general, what does that mean? It means that if you were to go out and play this game a lot, like 10, 20,000, a million times, if I were to average my results together, how much would I expect to win on average, right? And let's be clear, I'm going to win $0 and $5 about half the time, right? So that's not a lot of money, but there is occasional times, one out of every 52 tries, I'm going to win $40. But I'm going to win $10 a relatively fair amount of times, almost half the time, just about as many times as I'm winning 0 and 5. So when I add them all up, this is also how we calculate your grades in this class. You have a certain weight for each of the categories, and you have a certain number of points that go into those categories. And so you just multiply them up, and then you add those values together. And that's what we call expected value. The next question says, what would you be willing to pay if the game is fair? Well, what does the word fair mean in this context? It means that the person playing the game and the person hosting the game, the person that will be paying the money, has an equal chance of winning the same amount of money. So the expected value is the amount of money that the person's going to win every time on average. All right? If we're fair, then if you were to pay a certain amount of money and you were supposed to win a certain amount of money, then at the end of the day, if you played this 1,000 times, you should walk away with $0, just as the person who's hosting the game should also walk away with $0. Right? They're going to win as much as they pay, or they're going to pay as much as they win. So part C here, if I expect the game to be fair, right? So part C, I would expect to pay $6.83. Now, if I'm playing the game, I want to pay less than $6.83 so that I walk away with a profit. If I'm hosting the game, I want to charge more than $6.83. That way that I make money as I'm hosting that game. And so fair was where those two things are equal. Number 2, 3, 4, these are similar. Number 2 is exactly the same as number 1, but number 3 is a little bit different. I want to talk about that just as you set it up, and then I'll let you work on it, and then I'll post the key a little bit later. You can check your work. Number 3 offers a price, right? So when we set this up, we're going to have a number of, well, just one difference. Okay, the carnival game offers $50 for winning the game, right? If I pop the balloon, but it costs me $5 to play. So what I have to keep in mind is that when I'm doing a price, right, I need to keep in mind how many times I'm going to play, and I need to figure out exactly how much I'm going to win, even if I work backwards and figure out how much I'm paying. So if I pop the balloon in my first try, that means I'm really only going to win $45. If I'll pop it on my second try, that's $40, and then $35. Now I'm willing to spend up to $25, right? If the darts cost $5 at a time, then I'm going to have to I'm only going to be willing to pay for 5 darts. So 30, and then 25, and then at the end, I'm actually going to be doing negative $25 because there's a chance that I actually missed the balloon the entire time, right? If you pop the balloon at a 20% chance, whenever you get to your second, third, fourth, fifth darts, you have to remember, in order to get to the second dart, what happened on the first dart? You had to miss it, right? So if I'm going to throw the second dart, it's going to be 0.8 times 0.2. Darts are independent. It's 20% every time. That means there's a 20% chance that I pop the balloon. There's an 80% chance that I miss the balloon. And so I kind of have to keep that in mind. So the next part would be 0.8 squared times 0.2, and then 0.8 cubed times 0.2, then 0.8 to the fourth times 0.2, then 0.8 to the fifth power. And so this is a listing of all the different ways it can happen. Remember, you have 2 things happening, but as you add a dart to the list, you're adding a miss to that list, right? So keep that in mind as you're working these out. And this is essentially what expected value is. Try these problems. I'll post the key to this a little bit later on today. And if you have questions, let me know.